previous episode, the students stated that they didn't think they would be able to use arc length as a measure of angle rotation because arc length depends on the size of the circle. In this episode, they continue to explore these relationships by comparing the paths of the blades on two differently sized offshore wind turbines. Specifically, they find how far the tip of the 350-foot blade has traveled in 3 seconds and how far the tip of the 125-foot blade has traveled in 3 seconds. It takes both blades 5 seconds to complete a full rotation.
Okay, so, and then it said it was
5 seconds. So maybe we just
5
split it
seconds.
into maybe fifths. I don't know how we do that.
And then, wait, we can do the radius, because each blade length is at how long is it?
So for the first one, it's 350.
350. 50 feet. And then 5 seconds.
Okay.
And then for the other one, it was 120 feet.
125.
Oh, 125.
Yeah.
Okay. Because they both went around it in 5 seconds.
Uh-huh.
So they would have gone the same length, same
Speed.
speed, or like degrees in 3 seconds.
Yeah, the only thing that's going to be different is like the distance they travel because one has like a shorter blade. So like, because the distance is the circumference.
I
So that's going to be the only thing that's going to differ here.
I see.
So how do we calculate that?
Could you also describe your degrees in terms of like a fractional turn? Sort of like a fractional part of a rotation?
So wait,
Would it be 216 over 360?
it would technically be 3/5 of a turn then.
Yeah, that's what I was
Oh,
sort
yeah.
of wondering.
I hope that's readable. Well, I was thinking maybe what we could do is we could find that and then like divide it by 5 and then multiply that by 3
Oh, okay.
to get like 3/5 of the circumference.
Does that make sense to you?
You sure that makes sense?
Yeah. So we're just finding the circumference and then dividing
Okay.
it by 5 and multiplying it by 3.
Okay.
The students are now calculating the circumference of the circle by multiplying the radius by 2 pi.
What is our R?
350.
Times 350. Okay, now we divide it by 5.
So about
About 400.
439.8.
Yeah.
And what does that 439.8 represent?
Like a fifth of the
Of the
total
whole
circumference.
I see.
So 439.8. For 39.8. I wanted to make the approximate symbol, but it's like too close to the thing. Oh, okay. Yeah.
And now,
And now
where's our calculator?
it's the Google.
Oh, okay. And now we take that.
Make another line. $716
And then
times 3.
3.
So we can get to 3/5.
1,000.
319.
Okay. 1,319 about.
So here, I'm gonna like write up here like our answers.
Okay.
Okay.
So for 350, oh gosh, 350, it would travel 1,319.5 is what I'm gonna say.
Yeah.
Okay.
1,319.
1,319.5 feet
per.
traveled. There.
The students found the 350-foot blade would travel about 1,319.5 feet in 3 seconds. To find this, they first calculated the circumference of a circle with a radius of 350 feet by multiplying 350 by 2 pi. This told them how many feet the tip of the blade would travel over the course of a full rotation, about 2,199 feet. They then divided this number by 5 to find how far the tip of the blade would travel in 1 second, about 439.8 feet. Finally, they multiplied this number by 3 to find how far the tip of the blade would travel in 3 seconds, about 1,319.5 feet. Now they will perform a similar procedure to find the distance a 125-foot blade would travel over 3 seconds.
Yeah.
So do you want to go ahead and walk me through your picture?
Yeah, kind of.
We used the equation to find the circumference, which is 2 pi r, and we did that for both of them. And so we did 2 times, for this one, we did 2 times 350, or no, 2 times pi times 350, and then we found that, which I don't think
It
we have
was
written
this
down.
one.
Oh, and then that was right here, and then we divide that by 5, and we got about 439.4.
0.8. That's an 8.
Or-
Sorry, my bad.
And then we found that, and we multiplied that by, oh wait, actually no.
3.
Yeah,
Yeah, we multiplied
it
that
by 3,
and that's this.
and we got the answer up here.
Yeah.
That's
And
the
we
one.
did that so we could find we could first find
The-
1/5
Yeah,
of that,
and
then we multiplied that by 3 to get 3/5.
yeah, and then for this one we did the same thing except for we used 125. So we used 125 and did 2 pi r. So we did 2 times 125 or 2 times pi times 125. I keep doing that.
Yeah, it's okay.
Good.
And then we found this number and divided that by 5, and then multiplied that by 3, and we found that, and then we multiplied it by 3, and we got this number up here.
Okay.
And that is how we found our answers.
What can you say about the path traveled by the blades? So which one, if you could talk about the path traveled, like which blade went a farther distance and which one went a smaller
The
distance?
350-foot one. And that's because the radius is so large. Because if you count each blade as the radius, assuming that we're measuring from the center of the turbine, the larger blade is going to go farther because it's reaching out more. So it's woo. Whereas if you are only using half your arm,
Oh yeah,
you're only going
but if
a
you
little
use your
bit.
whole arm.
I'm trying to show it visually.
Yeah, that makes sense. Yeah.
You go the whole way with your whole arm, but if you use only half of it, you only go a little bit.
I see.
If you're waving to somebody.
Yeah. Hi. But
So in general, can you say that again? How does the radius relate to how far you go?
the larger the radius, the more distance you'll travel.
In this episode, Mary and Claire compared how far the tips of the blades of 2 differently sized wind turbines would travel over 3 seconds if it takes both turbines 5 seconds to complete a full rotation. They did this by first finding the total lengths of the paths of the tips of the blades over the course of a full rotation. They did this by multiplying the length of the blade by 2 pi. This worked because the circumference of a circle with radius r is 2 times pi times r. They then divided this length by 5 to find the lengths of the paths the tips would take over the course of 1 second, since it takes 5 seconds to make a full rotation. They then multiplied the distance the tips would travel over 1 second by 3 to find the distance they would travel over 3 seconds. These calculations showed the tip of the 350-foot blade would travel about 1,319.5 feet over 3 seconds, while the tip of the 125-foot blade would only travel 471.2 feet. This means the tip of the larger blade would travel a larger distance than the tip of the smaller blade, even though the angles of rotation for the two blades are the same. In the next episode, the students continue to investigate the relationship between an object's rotation and the length of the path it takes as it travels along a circular path.